Welcome everybody to our fourth fireside chat for the AI Accelerator. We have Roie here today with us from Pinecone. He's going to talk to us about embeddings and Pinecone, which is a vector database. And then I think he's going to also show us a demo of a chatbot built with Vercel and Pinecone. So Roie, thank you so much for being here today. And with that, please go for it.
Yeah, thanks for having me. I'm personally very excited about this co-op. I've been a Vercel user for forever. Love Vercel, love Next. So it's all good stuff. And yeah, like Hassan said, today we'll break up this talk into two parts. For the first, I'll just give you guys a bit of an overview about what embeddings are for anyone who doesn't know, sort of like a very quick initiation, and give you some intuition about what vector databases are and what they do. I know some of you are already using Pinecone, so bear with me on that. I hope to keep this intro part a little bit short. And then we'll dive into a more practical example. Since there are not that many people here, I'd love to take your questions. So honestly, if Hassan doesn't mind, you could just unmute and even share your video, and we could just like jump into like open conversation. I think we have about 30 minutes to do this. So let's get started. Okay, so I'll start by sharing just one application. Okay, so just the very basics, like what are embeddings? So embeddings are basically representations, the internal representations of machine learning models of all sorts. These days we use neural networks for the most part. Transform models are probably the most popular of those, but it boils down to the fact that there's some numerical representation in basically long lists of numbers that basically capture the relationships between different things, right? Those things could be words, they could be documents, they could be images. The important part here is that what gets captured is exactly the relationship between those different objects, and those relationships are being projected into a vector space, right? So instead of having those things represented as words, for example, we have them represented as vectors, but the essence of the relationships between those words is maintained and still lives within that vector space. So to get like a little bit of a more visual understanding of what that may look like, so here we have a bunch of vector embeddings in this 3D space, and these yellow embeddings represent terms that have some semantic correlation to one another. So in this case, it's the days of the week. And what we can see here is that what the embedding tells us is that these terms are correlated to one another, and they're actually dispersed in a close together within this vector space, right? So terms that are unrelated to one another or dissimilar to one another would appear farther away from one another in the vector space. To get more concrete about this, you can think of a word like bank, which can mean many different things. The meaning of the word itself is dependent on the context in which it lives. So for example, here we have, where's the Bank of England, and where's the grassy bank, and how does a plain bank? Of course, each one of these carries within it a completely different meaning, and that means that within the embedding space, this term is going to be embedded differently, and it's going to be actually farther apart from the other embeddings because it means something completely different. And then conversely, if we have two sentences that are using completely different words, but actually have similar meanings, they would be embedded in the vector space as being close together. So here we have the bees decided to have a mutiny against their queen, and flying, stinging insects rebelled in opposition to their matriarch. Again, both of these sentences mean the same thing, so they'd be embedded close together, even though they're using completely different words. Does that make sense so far? People nodding heads. Thank you, Hassan, for the feedback. Okay, cool. Okay, so let's talk a little bit about vector databases. Vector databases, as the name suggests, allow us to manage vectors at scale. Unlike traditional databases, you don't query them with strings, you don't query them with numbers, you query them with vectors. So we use them to quickly insert and update and delete vectors. And then we have our query vector. And when we query the database, it uses a similarity metric, for example, cosine similarity, Euclidean similarity, or dot product similarity, and then retrieves the vectors that are most similar to the vector that we queried for. Now, it doesn't only store vectors, because that would kind of be a pain to have to like go ahead and stitch together other information from other systems. And so we can also associate other metadata with the vector, right? So for every vector that we store in the database, we can store metadata that's associated with it, whether it's the text that the embedding was created from in some cases, and in some other cases, it could be some categorical data, some user information, anything that's going to be helpful for us to then build applications downstream. It comes in to be very useful because it kind of gives us a way to track and understand what the embedding model actually is doing in relation to the content that we are interacting with, right? So in a lot of cases, in the example that I'm going to show you soon, you'll see that we can basically embed the actual content and then save that content or some reference to that content, some ID that refers to that content, and then later on say, okay, so there's some correlation between a particular piece of content and that embedding. And later on, when we retrieve those embeddings, we can leverage that information to give some sort of an explanation as to why the behavior of our application is the way that it is. So it kind of gives us, as opposed to interacting directly with a model, you're not just like running an inference query where you're getting back some classification or some completion or some result that is sort of opaque. When you're using a vector database, you have the opportunity to associate, again, the embeddings that the model spits out with metadata that kind of enriches that embedding, and gives you a little bit more of a handle on what it's doing.
Can I ask you a quick question, Roie, before you get into the architecture?
Yeah, go ahead.
Thanks. So back on the previous slide, you talked about, so let me actually give an example. Like, let's say I'm trying to embed a code base, because I know a couple of folks here are working on dev tools, right? I have a code base I want to embed. I had a question about the metadata. Would the metadata be, for example, the file from where I brought a specific block of code? Would that be the most relevant thing to do? Because then I could kind of cite.
Yep, it could be exactly that, right? Like, and it really depends on what your application needs, right? So in your case, right, like if you want to show some reference to the code, it won't be even enough to if you again, it depends on what you're embedding exactly, right? But it might not even be enough to just give me a file reference. Maybe you want to give me the specific line, right? Or even more granular information, like what code block was this in, right? And again, it really correlates to what exactly you're embedding, right? Because there has to be some correlation between the chunk of information that you're embedding and whatever reference you're giving back. Does that make sense?
Gotcha. Yes, that makes perfect sense. Also, a lot of folks love the graphics from the slides in the chat. So shout out for the great graphics in the presentation.
Thanks. I didn't make these so far. So thank our visual designers, graphic designers. Any more questions before I continue? Okay, cool. So how do these applications work in general? So like I mentioned, right, like you in most cases interact with some content, right, we can call our knowledge base or whatever. And the first phase of the first phase of building the application will be to take the content, embed that content, and then save those embeddings in the vector database. And then the second phase would be the application. When an application actually wants to interact with that content, it will use the same embedding model that was used to create those embeddings in the first place to then retrieve the data back from the vector database. As you can see here, we're retrieving back the set of similar results to the one that we queried, and that will be the query result. That's basically most vector database dependent applications require these two steps. In terms of use cases, there are many. They start from semantic text search, which is like the most obvious use case where you just have a set of data that you want to search over semantically. The value there is that users no longer search for keywords specifically. They don't have to kind of back engineer the search engine, but rather search for whatever they actually mean. And the semantic text search engine is going to handle the ambiguity within their search, and that again leverages the fact that it uses an embedding model in the back. Same goes for deduplication. So when you have content that doesn't necessarily match one-to-one, you could leverage again that ambiguity, the capability of the engine to handle ambiguity to do better deduplication. Recommendation engines are very common with this. So again, we can look at the behavior patterns of users doing different things, interacting with different things, and create vectors from those, and then find content within our knowledge base or whatever the vector database in general to that would correlate with those aggregated vectors. Other use cases are image search and audio search. In those cases, the vector database doesn't really care where the embeddings come from. As long as you embed something, you can use the vector database with it. So if you can embed images, you can do image search. If you can embed audio, which is basically image search in some way, you could search through audio. I won't touch on all of these because it's going to take too long, and I'm already over time. So I'll just touch on question answering, which is what we're going to do today. So basically, that's perhaps the most well-known use case nowadays. People are building chatbots left and right. The basic premise is well known, right? You can use generative AI models to generate new content, given some prompt. The use cases for these applications are numerous, right? Like from legal to, I've seen so many different use cases. Really, the list of is endless. But the biggest problem, right, that generative AI has in general is hallucinations. And one of the ways to tackling this problem is by using a vector database and using this retrieval augmentation pattern, which basically means that instead of just like letting the model, which is pre-trained and doesn't necessarily know about the content that I as a company might have, I will create a vector database index that carries within it that information, and then take the user's query, embed it, and search for the most semantically relevant documents within that within the database, and then push those, basically inject those into the context of the chatbot, and that basically and with some a little bit of prompt engineering, we basically force the bot to answer the question based on the semantically relevant information. Go ahead, Hassan.
Yeah, you said create an index. So what's an index?
So an index is kind of maybe like just like in our parlance, kind of you think of it as a table, right? It basically has like all of your embeddings, the things that separates indices from one another. Indexes, I guess, is a Pinecone term, but basically what separates them from one another is the dimensionality of the index. So like different models produce embeddings with different dimensions. And so you would use, you can't mix and match. So a single index would be used for embeddings with a single dimension. So for example, if I'm using OpenAI's embedding model, it would be like 1536, right? If I use 802, it'll be 768, right? So that's basically what an index is. Yeah, it kind of like there are also other considerations of how you control scaling, and whether it's vertically or horizontally. Like you can have multiple indices that have different scaling capabilities, right? And so we've seen people use even like you can have multiple indices with the same dimensionality, but they're used for different purposes, and so they could be broken up for that reason as well. So just a word about Pinecone before we wrap the slides up. So basically, Pinecone is a high performance vector database. It's fully managed and distributed, which lets it scale basically infinitely. The biggest indices we've seen so far are up in the billions of vector embeddings. The importance for us is to maintain performance throughout, whatever scale we're dealing with. So sub 100 millisecond latency, and there's more throughput information that you can find on our website. I'm not going to go into that right now. And of course, it doesn't come, just performance on its own is not helpful. It has to be also cost optimized, so you don't have like a bill that you can't deal with. So Pinecone really focuses on managing both of these things, both scale performances and cost. Go ahead, Hassan.
Sorry, I keep interrupting you.
No, you're fine. This is good. I want the interactive,
Awesome. Yeah. So you were talking about vector databases. Can you talk about what the difference is between a vector database and a traditional like Postgres database? Because I know I've seen a couple of Postgres databases come out with, PG vector or PG embeddings, and they're saying, oh, you can use our Postgres database for your embeddings. Like, why should someone use a vector database like that's specialized for this stuff?
So this is like not a new phenomena in the sense that you could use back when the graph databases were starting up. Everybody was like, oh, you could just do a graph database in your Redis or in your Postgres or whatever. And the answer is you hit problems when you get to scale, right? That's the bottom line, right? When you're not dealing with a database that was purposely built for dealing with the content type that you are dealing with, but it's kind of like more general. It might work in smaller scales, but it will not scale the way that you expect without challenges. And that's been our experience, right? We've seen a lot of customers that have used other databases before coming to us, and then just like hit some ceiling when either performance wasn't sufficient or cost went up way up because they had to scale it in really weird ways. It's kind of interesting to note, on that point, right, that like Redis had like its own little graph database that they had to sunset very recently, and while Neo4j, for example, is still reigning supreme in the GraphDB world, and then other vendors kind of followed suit by like coming up with their own specifically purpose-built graph databases. I think that's the case for us as well. Again, like you could in theory, in a lot of cases, you don't need a vector database at all, right? You could just use a vector index. It would just negate a lot of benefits that you get from using a vector database, which is again ease of use, scale, etc. It just really depends on your situation. If you're dealing with like hundreds of embeddings, don't even bother, right? Like it might not be for you, right? In most cases that we've seen, people are dealing with at least tens of thousands of embeddings that they have to interact with and update and delete and sort of like make changes to, which isn't trivial to do with the vector index. And so that's where they sort of start using us. And again, like I think that the most important thing is as a developer, the thing that you could pull up and start running with without having any kind of headache with is probably the thing that you would reach for first. And then it really depends on whether or not you believe it could scale up, right? So like depending on your situation, again, if you're in an enterprise scenario, in an enterprise kind of situation, then you might go for like the open source blah to just start with, but then you find out that, well, like actually there's like other considerations. There's like whether it's security or being HIPAA compliant, like all these different things that you don't necessarily get for free, quote unquote, from open source solutions. And this is not knocking on open source. I love open source, right? But there are certain things that like you can only do so much on your own. And that's kind of like the main appeal with Pinecone.
I love that. Thank you so much for the answer. Alex actually had a great question in chat. Alex is running Intuita, by the way, which is an AI powered code evolution platform that helps with like mass code migrations and refactorings. Just for some context, but he asked a question that I think will feed nicely into the second part of your presentation, which is how easy is it to get started and see a simple project working with Pinecone? Can you quickly show us a demo or walk through a web app?
Sure. So the answer is yes. Okay, I'm going to stop sharing for a second and then do this magic of Zoom. And hopefully you can see both of my apps right now, like the browser and the.
Yep.
Yes, perfect. Too small, too big. Just the right size. Everybody can read the font and whatnot. Yes, good.
Looks like we have a couple yeses. Awesome.
A couple of yeses. Okay. So at first, I kind of plan to run through this whole thing step by step, but I'm not going to do that because we're running out of time, and I hope basically have like 5 to 10 minutes to go over this. So I'm just going to go to the very, very end here. And okay, I'm going to refresh this. I'd have to kick this guy again. No, it's compiling. Boom. Okay. So I just built this app in 2 seconds. No kidding. So this app is actually pretty easy to build. And this is a lot thanks to Vercel's SDK. Honestly, it like everything that has to do with chat, like you don't have to think about it anymore. You can just build the chat bot in literally 2 minutes with the new Vercel SDK. Just to explain a little bit about what's going on here. So I'm using the use chat hook that Vercel provides, the AI SDK provides to handle everything that happens in the front end. So updating the messages that you see here. So if I just say like, I'm just going to clear this index so that we don't have noise. I'm going to say hello. And you'll see that I get back a message that will say, hello, how are you? That's great. All of that happens just by using the AI SDK. So you see here, there's like a message area. Down here, I have like this chat box, and it just takes this messages variable, and all the state and all of that stuff just is taken care of. And it talks to this endpoint called chat. Again, this is something that mostly is done by Vercel. So other than this get context, which is the function that I'm going to talk about for most of this part, everything here is basically done for us by Vercel and OpenAI's API, the Edge optimized API, which allows us to run these functions on Edge. So basically, I'm grabbing the messages from the client. The chat hook just knows to send them to the /chat route. Of course, you can modify that if you want. And then it calls the OpenAI API for a completion. It passes in the prompt, it passes in the messages, and then streams that response back to the client, right? So that part is super uber easy. You can literally get that set up in 5 minutes if you'd like. Where it gets interesting is where we start thinking about, okay, so like, I want this bot to understand a little bit more about the world than what it usually knows, right? So if, like, for example, if I ask this guy, what can you tell me about deforestation in Indonesia? It's probably going to say, I don't know that much. Actually, it does know so much. It knows a bunch. Okay, let's make this answer, make this question a little bit more specific. In 2023. Okay, cool. So it doesn't know a lot about it in 2023, but then it starts talking about whatever the stuff that it does know until that point. Okay, so if we wanted to make this a little bit more aware of again, content that is maybe outside of its immediate purview, then we would have to go and fetch some information and then do something with it to make it part of that context, like I said before. So let's look at what get context does. So again, it takes the last message that I just sent. It gets it embeds that message, right? So again, we don't have to really go into how that happens. It just calls the OpenAI API and gets an embedding. You can do that in many, many different ways to get an embedding, right? And then it does something called get matches for embedding. So it's actually here going to go to Pinecone, and it's going to make a query. It's going to take that embedding and it's going to look through a particular index that I've created and see what query results are matching, right? Now, what's inside that index is the following, right? So when I click on this button, I'm actually going to kick off a crawler, and the crawler is just going to go and fetch a page, right? So like there's really nothing too much going on in here, right? It's going to fetch that page right here. And then it's going to do something called splitting, right? So I'm going to take this document and split it into chunks. How do I split this? And this is where it gets a little bit more technical. So there's a lot of different ways of splitting. I'm going to demo maybe two of them here, or talk about two of them here. One of them is what's called recursive text splitting. And recursive text splitting, I could basically say, what is going to be my chunk size? And then what is going to be the overlap between the chunks that I'm creating? But basically that means that my splitter is kind of dumb in the sense that it doesn't really know about the semantic meaning about the portions, the sections within my text. But it's just going through like the actual values that I've given it. The other type of splitter that we have here is a markdown splitter. And that markdown splitter does something a little bit smarter. So what I didn't tell you about this crawler is that it crawls the data and it also turns that HTML into markdown. So then now we don't just have just simple HTML, we actually have cleaned out markdown with headers, with paragraphs, and so on and so forth. And the markdown splitter is taking advantage of that, and it can basically split these portions into segments that actually make sense semantically, right? Mm-hmm. Because that's kind of how the structure of the page was built in the first place, right? So then when I run through this process again, and I go to, seed, I go through this process, I split these documents, I then create vectors, right, for all of these segments. And again, creating these embeddings is as simple as calling get embedding. I get back vectors. As you can see here, what I'm saving is basically I'm identifying each of these segments with a hash. So this is the hash that you can see here on the bottom of each segment. And that's going to be my ID for the document, so that if I say like want to update it or whatever, like whatever segment that I already have is just going to be overwritten. And then I save the actual chunk text, which is not necessarily required. I save the URL, and I happen to save the hash and the metadata as well. And then I return all of these as vectors, which are basically a Pinecone type. And here I basically call chunk upsert, which basically means that I take all of these chunks and I upsert them in chunks, right? So I can have hundreds of chunks, and it will just go through and upsert them right here. I'm doing it in chunks of 10, but I could do it in chunks of 20, whatever. There's some limitation to the size of chunks that you could upsert in every operation to Pinecone. So this is just like a helper function that like helps us not think about it at all. And by the end of this process, I have like the web page that is here completely embedded and saved in Pinecone. So then if
Can I ask you a quick question, Roie?
Yeah, go ahead.
Yeah. So just so I'm understanding correctly, we're starting with a bunch of text. In this case, you're scraping some web pages about Indonesia deforestation. You're sending it to the OpenAI embeddings API to embed them,
Yep.
and then you're splitting them into chunks and putting them into a Pinecone database.
Before, so like I'm splitting them and then I'm embedding them.
Okay, got it. You split and then embed. So can you talk to me about this splitting process, this chunks? Why can't we put everything in one chunk? Why do we have to like break it down into all these different chunks that we're then embedding? How does that process work?
That's a perfect question. So so what you'll see here when I actually ask the question again is what I'm going to get is number one, the response, right? So the response is going to be not just like what it said before, I apologize, blah, but actually an actual result. But I'm also going to get the specific chunks that are relevant to answer this question, right? So like it just highlighted for me, hey, like I got these from these chunks, right? So why is this important, right? This is important because if I took the entire document and just embedded it, right, then essentially every query that would have some semantic correlation to the entire document would hit the entire document, and I would just get one result, which would be the entire document. What you want to get is a little bit more refined, right? So like I actually want to get smaller chunks so that my answer to the LLM is actually going to be a little bit more specific, right? So if you see here, what happens is when I write in chat, what I do here is basically I get the context, and then I basically tell the AI. So up here you see there's like this prompt, blah blah blah, not very interesting. It's just like your normal chatbot prompt. Then I'm saying, hey, I'm starting this context block, right? And I just found that this is kind of like a way to do this. It's not like a prescriptive way to do this. It's just a way to do this. And I inject that prompt, and then I tell it, please take into account any context block that is provided. So like if I have multiple of them, it will take them into account. If you don't have an answer to the question, so just say, I don't know, right? But like really focus really on this context block, right? Like don't invent anything that you don't know, but only look at the context block to respond, right? Now, that's exactly what makes this augmented bit work, right? So like I've done the retrieval, this is the augmentation bits, and now it could do this generation in a way that's more accurate, right? So like it tells me exactly what happened in 2023. If I look at the content that was actually highlighted, I see that when it says here between the years of 2015, 2017, and blah 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 blah, and then I look at the actual content, and I can see that's what was referenced, right? And wow. That's kind of like the point of like having this ability to not just rely on the things that the LLM knows as it was pre-trained, but rather have content that I created, right? And I associated. So like I was the one who associated this particular chunk with the embedding, right? And because I can say there's a correlation between the query embedding, whatever I wrote as the prompt to the bot, right, as my question, right, and this content, right, this must be relevant, right? And that's kind of like the magic of retrieval augmented generation. And that's basically the long and the short of it. That's all I had. That open to questions.
Wow, I love that. That's yeah, that makes perfect sense why we split it into chunks. In this case, I guess it's not like the hash, I guess, isn't too useful, but like if we were, for example, embedding a couple of environmental journals and the answer could tell us like, this is the answer and the source was this specific journal, right? Like it could actually like cite its sources.
Yeah, I mean, again, it's like there's many ways to there's many ways to do this. For example, right, like if you want to, so like if I took a journal, right, like, and if there's like there's like citations within it, for example, right, when you could do all sorts of tricks with chunking, right, and say, hey, like if in this chunk you find a citation, right, save that as part of the metadata. And then when you retrieve, you could like literally use like this context, right, to and break it into parts, right? Here's the text that's relevant, and here are the citations that are relevant, right? And use the citation as part of a response. And that's in most likelihood what ChatGPT does, what Bing does, and when they're doing their citations, right? There's like this combination of like prompt engineering and smart chunking and like manipulating the metadata in this way.
I love that. Thank you for the answer. Yeah, so we're open to questions. If anybody has any questions, I see one in the chat right now. I'll go ahead and ask that, and then we can move to Chris, I think, if you had a question. So Ying asks, is there a way to view the required upsert schema for an existing index?
The required insert schema, yeah. So it basically looks like this. In here, right here. So you basically need three things. You need an ID, you need the values, and you need metadata. And the metadata is basically just a JSON object. There's a limit to how big this JSON object could be. It's up to 40K. And there's a couple of things to say about metadata. So within the metadata, you have the ability to select which of the fields you actually want to index on. You don't want to necessarily index on all of the fields. Basically, you want to be selective in the sense that if you have a very high cardinality metadata index, it's going to hit. You're going to get a hit in terms of performance. And so what you'd usually index are things that are categorical data, for example. In most cases, those are the things that are most useful to query on and filter on, because that's basically what metadata is there for. And the rest is kind of like you're just wanting to store, right? So in my case, when I create my my index, I can basically say, there's a way to configure that index and tell it to not index particular portions of my metadata. And in that sense, like I can store my text, I can store other things that are just going to be stored there, but not going to be indexed. And that way, I'm not going to take any kind of performance hit.
Amazing. Thank you for the answer. Let's go with Chris and then Will for questions. I don't
Chris,
think we can hear you, Chris.
Muted. Yeah.
Sorry, can you hear me now?
There we go. Yes.
Hey, I was saying this is a great presentation, and I really appreciate that you're using Vercel SDK, because it's really relevant to what we're working with right now. Something I was wondering about is, how do you deal with two pieces of content that are similar but have contradicting facts? So maybe an article from 10 years ago when something was untrue, and then an article that recently came out and maybe the thing that the facts have changed. How does that work with retrieval?
So it depends on how you retrieve things. I'm pretty sure that if there's a sentence that says like, fact X is true, and then another one that says fact X is not true, if your query is going to ask about fact X, it's going to return both. If your query will ask, is fact X true, it's going to return the true statement, probably, as being more similar to what your query is, right? But again, like it's an interesting question whether or not like the embeddings actually capture the meaning of truthfulness or not truth or falseness of statements. My intuition says that it does. But again, it really depends on how you're going to interact with the embedding to kind of like force that information back out. I haven't personally done anything in that sense, so I can't speak of it like very authoritatively, but it's an interesting question. My gut tells me that it should be preserved.
Do you mind if I ask a second question?
No, go ahead.
How do you think whenever you have separate kinds of content, so maybe you have a help desk content and you have news articles, do you put that all into the same I guess, like database in this case, or do you separate them out? And then how, if you had one chatbot here, how would you think about retrieval across the different places that they're stored?
Yeah. So one of the ways of separating things out is by using metadata and categorical metadata, right? So if you think about it, right, like for example, if you had say two categories, right, health and I don't know what your other category was, sorry, you could have like them that stored in the metadata, and when you filter through those categories, basically it creates a subset of that category and then searches the embeddings through that subset, right? So you actually gain performance in that sense. So we've seen that happen a lot. In most cases, the separation of like the cost factor here is also important. So basically, you pay more as you have more indices, and so you kind of want to err on the side of having less indices if you can help it. And so really, like the biggest factor in deciding which like if whether or not to create a new index is whether or not you're using the same embedding model, which would have, you know, repercussions in terms of like the dimensionality and like the actual way that things are embedded. Because even if you have two completely different models that have the same dimensionality and you're going to use the same index for them, that could be noisy and problematic, right? So in general, like the recommendation is, you know, use one index per model that you're interacting with. And then secondary to that is, you know, you can use metadata, you can use namespaces, which might be deprecated later, but like you could definitely use metadata to do most of this categorical filtering that you mentioned.
Thank you. Go ahead, Will.
Yeah, hi, can you hear me?
Yep.
Cool. Yeah, great. Really good talk. About the like cardinality of metadata indexes. To me, that seems like a problem for like if I'm storing documents for a bunch of different users, and like when I run a query for one user, I only want to search the documents relevant to that user. But like user ID would be like a very high cardinality field, right? Is that just like not very well? Is that like not a thing Pinecone's trying to support well?
So for now, the best way to go about this, again, this is assuming you don't need to search across all of the users at once, and that's a big assumption. You can use namespaces, which is you're basically creating a sub index within the index itself. This might change when in our next release a little bit in terms of how that particular implementation behaves, but you'll still have the same functionality. It might just look a little bit different. But that's the basic premise, right? Is like you're creating a sub index within the index that you're storing your things, but that kind of limits you on the other end in searching throughout that whole index, right? But again, like in some cases, and again, it depends on the scale, right? It might not be like that prohibitive to even index high cardinality fields. Again, it really depends on your requirements, right? Like your throughput requirements, and so on and so forth, latency requirements.
Cool, thank you. And yeah, can I ask one more question?
Sure.
I was wondering, a lot of my use cases for vector databases are like the data is more like structured, like it's a JSON with like a specific schema. Do embeddings do a good job of like understanding, okay, this word is in this place, like this is under this field name, and this one's in this place. So like if I have this word in this one in like under variable 1, it's not the same as like this document that has under variable 2.
Yeah. So it depends on the embedding model, right? Okay. Most embedding models have been trained on natural language, right? Models that have been trained on code, for example, might do a much better job at this. That's just to say, my personal response is I have no idea, but it sounds like super interesting to try it out. But like my intuition tells me that like models that have been trained on code would be much better suited to do this than models that have that have been trained on natural language.
Like using codecs for embeddings,
for example. Yep.
Okay. Cool. Thank you.
Yeah, no problem.
Awesome. We have a quick question in the chat, and then we'll go to Aman. So Ying asks, how should we think about deciding the chunk size and the chunk overlap? Like, what's a common number to pick?
This is a really common question. There is no hard and fast rules here. I've seen people use 256, 512, 1024 with varying degrees of success. It depends, like, again, like always, it depends on the use case, it depends on the content, and it depends on what you're expecting to see to come back, right? So it will require a lot of experimentation. My own personal preference, and this is why I showed this markdown splitter, is to not use a recursive text splitter, because again, it doesn't know anything about your content. It just kind of guesses as to like where it will start and end. It might work well for you, right? Like, I'm not going to disparage it completely. It might work well for you, but you should definitely experiment. And this is kind of like a good environment to do it in. So like this demo kind of like lets you play around with different chunk sizes to see like, oh, what happens when I do this? What happens when I do that? How does it affect my my responses, like the answers that the chatbot actually gives back?
Got it. Thank you. All right, Aman, go ahead.
Yeah, my quick question is, first for context, I'm like new to building things with embedding similarity search. Right now, I'm just like playing with the Facebook AI similarity search library, and I was wondering, is there a practice or a tool that Pinecone provides that would? I know we mentioned metadata helping us like search things, but is there a way to figure out what indice would be best for your use case? Because from what I'm seeing is if you want to have improved accuracy, you'll sacrifice performance. If you want to improve performance, you'll sacrifice accuracy. So is there a way to like figure out what, like, is there a practice or a tool that will help you like what's in the middle ground between the two?
So right now, my best recommendation would be to not worry about it so much, right? Like when we're talking about, performance and accuracy, the differences are going to matter only when you're at real big scale, right? If you're just getting started with it, you could just start with our starter solution, and it would be more than enough for what you need. I like, again, you won't necessarily even know, right? Like that something is accurate or inaccurate, right? If you don't really have good evaluation tools to like say like this is what I'm expecting or not expecting. So you probably wouldn't necessarily quote unquote know, right? If it's doing a good job until you actually have it working in your app, which is probably the best way to evaluate these things. And in terms of performance, like I said, like until you get to like millions, I mean, hundreds of millions and billions of vectors, that's not going to even matter, right? Where really it does start like mattering is for people who are doing really large scale solutions, and in those cases, we there's definitely trade-offs that you could start thinking about. I hope that wasn't too big of a cop-out, but
no, that made plenty of sense. Thank you.
All right, looks like we have one more question and then we can close out. Benjamin asks, how does Pinecone compare to Milvus, which I just looked up and it looks like it's another vector database. I don't know if you've heard of it, Roie.
Yes, I've definitely heard of Milvus. I'm not gonna talk about Milvus specifically, but I'll just tell you what we are good at and what we pride ourselves in. Again, being a fully managed service means that you have the least amount of headache getting started, and that you have the assurance that this tool is being used by giants like Shopify, right? And if they use it, that it scales, right? And so like that, I think gives you, like, takes care of both, like both ends, right? Like getting started very easily and getting your work done. And then on the other hand, knowing that you could just continue with this tool and keep growing. And that really is what sets us apart with our competition. And that's the very politically correct way of doing this, but I am representing
my
Pinecone.
question is, why do I want to use a managed service versus not use a managed service? I'm trying to figure out between vector databases, what sets them apart from one another?
I mean, it's usually the performance characteristics, right? Like, and that's something that you'll be able to see in really large scales, right? And so you could try out Milvus with, you know, the MS Marco data set, for example, and compare it side by side with Pinecone and see what you get.
Cool.
Quick question, if that's okay.
Go for it, Will.
Yeah, it seems like everyone uses k-nearest neighbors as like the default algorithm. Is there ever any other reason to like choose one of the other ones, like L2 or cosine?
Under the hood, first of all, you shouldn't worry about it, right? Because that's kind of like the
that's
whole
fine.
point.
That's a fine answer.
Right? But actually, because we're distributed and because we're shooting for scale, we're actually not using k-nearest. We're actually using approximate nearest, and actually not even that. It's like a modified version, proprietary modified version of that. So yeah, like there's again, like the beauty of Pinecone is that you don't have to worry about this stuff, right? Like you just come with your embeddings. We'll give you the fastest, best, most accurate response, and you can go about your day worrying about the rest of the application.
Cool.
Great. Well, if there are no further questions, thank you all so much for coming. Thank you, Roie, for coming and spending your Friday evening with us, educating us about Pinecone, and thank you for being involved in the AI Accelerator. Pinecone, you know, generously has offered everybody $300 of Pinecone credits. So for those folks who applied, you should see it in your dashboard. If you don't, you can email me and I'll coordinate with the team. But yeah, really appreciate you coming and talking to us.
Yeah, it was super fun. Thanks for having me. And if you guys have questions still, I'm here. Find me on Twitter, find me on email, whatever. I'm more than happy to help.